Okay guys, so we're on to area of trapezoids and random quadrilaterals. Okay, so if you're, a lot of you will just be doing the area of the trapezoids part of this, and then those who are thinking about moving on to advanced, you're going to be doing a little bit of additional work to help you get ready for the additional skills that you'll need and thinking that you'll need for the advanced level next year. Okay, so what do we already know how to find the area of? Remember, we already know how to do rectangles. Base times height. We know how to do triangles. 1/2 base times height, and we know how to do parallelograms, which is also base times height. Okay, so those are the shapes we've already done before. So hopefully you can just list those off real quick and be able to do those. We also did some in the beginning where like it was you combined rectangles and you had pieces stuck to each other. So right, you could have combinations of shapes. Of these polygons. Okay. Oh, we've also done the area of a circle. Right. We also talked about how to find the area of a circle, pi r squared. Okay, so we have these four that we've already done. So now we're going to talk about a trapezoid. You may or may not remember that a trapezoid has only one set of parallel sides. Okay, it's a quadrilateral. Only one set of parallel sides. Okay, ourself. And it's important to underline only one set. If it had two, it would be a parallelogram there, right? So, right, that's the key thing. So, how could I find the area of a trapezoid? Well, there's a couple different ways, right? So, let's say we have a trapezoid here, and we could just take the two ends and break them off, and then make some rectangles in a triangle. We have a rectangle in the middle here. And then we have our triangles here. And the nice thing about it is it doesn't matter how you broke it up. So if we had an example here, if we decided to use this technique, okay, and let's say that this was 6, and this down here was 14, and it's given here that the height of this is going to be, I don't know, let's go with 4, okay? What we could do for ourselves is we could draw in, let me get a different color here. I could draw on the other side's height, make a rectangle here. That rectangle is 6 by 4, so that rectangle is 24. Okay, and then we know this is 6, and so we have 8 left over, and we can break this up however we want. So if you want to make this 3 and that 5, that 2 and that 6, it's going to give you the same area. It doesn't matter, right? Most people just choose to make it 4 and 4. They're in the sense that like, oh, there's 8 left over. They decide to cut it in half. So it doesn't matter. So this could be 4 and 4. It could be 2 and 6. It could be 3 and 5. It could be 4 and 4. But it won't actually change your area, which is pretty nice. The area of this then, 1/2 base times height. So 4 times 4 is 16, half. 4 times 4, 16, half. So the area of this whole thing would be 40. If I had broken this up into 3 and 5, I would have gotten the same exact answer, right? It was still getting me 40. It doesn't matter. If I had done 2 and 6, right, same exact answer. 1 and 7, 1.5 and 6.5. It doesn't matter. It's always going to be the same, okay? So that's method 1 there, is to just break it up, okay, like that, okay? And that's a great way to go, all right? Another method that some people choose to use, right, instead of breaking it up like that and having a rectangle and 2 triangles, they just break it up like this. They draw one diagonal in. Like this, okay? And with that diagonal, they get 2 triangles. They're going to have a triangle in purple right here, okay? And we know how to find the area of that, right? Okay, we do, right? And then in the top here, and I'll get green for that. Okay? Triangle that's green, okay, for myself, and they can get, and so both of those we can find the area of. So if, for example, let's do the same example. Oops, that doesn't look the same. I'm trying to make it look the same as the other one. Remember, 6 here, 14 here. And we had our height. Okay, and that height was given as 4. Okay, you could draw the diagonal, and I'll draw it this way so I don't go through that. And here's one triangle. And that triangle is 1/2 base times height, 28. 28 for this. And then the other one, in green here, okay, I'm going to spin it around to look at it. All right, this has a base of 6. Its height, well, the height's the same. Right, this triangle and this triangle have the same exact height. They have the same height of 4. Right on. So it's going to be 1/2 6 times 4. And those heights are always going to be the same. So you don't have to worry about it and say, oh, is it just that problem? No. Nope. Always going to be the same height. That's going to give me 12. Add those two together. I get 40 overall for my area. Right? Okay. Now, some of us, let me just look ahead and just make sure, yep, okay. Some of us, right, we are looking at that and you're thinking to yourself, I'm not sure about making rectangles and triangles or making 2 rectangles. And guys, I'm going to tell you that these 2 methods are probably the best ways to do it, because that way you don't have to memorize a formula. Formulas are great until you forget it, right? But some of us, we really want to use a formula as we do this, and that's fine, okay? You do what you need to do. But if you're going to use a formula, you have to remember it. So if you have memory issues, don't do this, right? But there's a formula method. Okay, and that is the area is 1/2 base 1 plus base 2 times height, which is kind of like what we just did right here. Look, we have the 1/2, we have the height in both of them, but what's really happening is you're adding the 2 bases together, which is, remember, we added these together, so really this method right here proves this formula right there. Okay, so if you want to use the formula, go right ahead. You're not going to see me use it very much for myself, right? Because I am such a visual person. Okay, so let's go to example 1 here. Okay, so if I'm looking at this, right, let's find the area of each trapezoid. It's telling me a trapezoid. Okay, so I like the diagonal method. That's what works well for me. Okay, and I use my 2 colors to highlight my triangle for myself. Okay, if I look at the triangle in green, whoops, sorry, let's focus it there. Okay, if I look at that triangle in green, it's a triangle, 1/2 base, height is 6. Notice 7's not the height, it's not at a right angle. Okay, so that's 6 there. Okay, so half of 12 is 6 times 6 is 36. Okay. The purple triangle, I'll spin it around for myself. Here's the height, right? That's at a right angle. So the height is 6, the base is 5. 1/2. 5 times 6. And this is going to be then 15. Add those 2 together. 36 and 15 together is 51. All methods should give you 51. So if you say, oh, I got a different answer because I did it a different way, then you did it wrong. Okay, it has to be that same answer for yourself. Okay, no matter what. Okay, so that's how you do A. Right? B is exactly the same. C is a little different. Here's how C is different. Right? You want to notice, right? And this is trying to get some people sometimes, right? So you have to be careful. All right, let me zoom in a little bit here. Okay, if you're looking at it, the weird part about this is that only this is 11. Okay, and you're going to see this sometimes on the homework. That's kind of unclear, right? But see, since this 11 is centered on that, that's how you know that that's just 11. Okay. So if I'm looking at this example, if I'm going to use my technique of like, hey, putting that diagonal in here, if I'm looking at the triangle in green, I know that the height of it's 8, but I'm not sure what the base is. I know that part of the base is 11. What could this be? Oh wait, there's a right triangle right there. Okay, so this is our first example where we're using right triangles to help us as we do this. Okay, so right, just put a little star above this. Right, use Pythag or triples to find missing info. Okay, and that's going to happen a lot, right? You're going to have this pop up all the time. Okay, so, oh, that's a triple. 6, 8, 10. So that's 6. So that means my base altogether is 17. By the way, if you didn't recognize that triple, do the Pythagorean theorem. You'll get the same answer. You'll just do more work. Okay. Height's 8. Right, so this is going to be then, let's see, I'm going to do half of 8, which is 4 times 17, that's 68. Right, so this is 68. For this triangle in purple right here, the base of it is 9. I'm kind of looking at it upside down. The base is 9, the height is 8. And if you're like, wait, where'd you get that? You just spin the paper around and look at it. Base is 9, height is 8. 36. Add those two bad boys together. 104, there we go, is their height. Okay. D is going to be similar in the sense that, hey, wait, I need to figure out but in this case I need to find the height there, right? So this time, like here, it was actually drawn for us, the height. I'm going to have to draw that height in. So you draw the height in. And if I look at that, hey, look, I can see I have a right triangle right here. Oh, it's a 30, 60, 90 right triangle. So this right here then is 5, and that's 5 root 3. So we're practicing those special rights. Okay. Now, I was a little careless here. Remember, originally this wasn't here, so I should have, before I started, I should have mentioned, hey, this whole thing's 13. So that's one of the things I would do. If you're going to break it up, you want to make sure it's clear that whole thing's 13. It's not 13 plus 5. Like up here, it was the 11 because we already had the height in there, and that was telling us that piece is 11 there, right? So you have to be really, really careful as you do these ones about which part's given. So I should have crossed that out and put the whole thing as 13 to start. Okay. Now I'm going to use the diagonal technique. Put the diagonal in. There's my triangle. That green triangle has a base of 13, a height of 5 root 3. 13 times 5 is 65. Divide it by 2 with a root 3 afterwards. It's the first one we see there's a root 3, and that's going to happen. That's okay. Right. The purple triangle has a base of 7. The height is also 5 root 3. Those heights are always identical. I get 35 over 2 root 3. If I add those together, that's going to give me 100 over 50 root 3. That's my answer for myself. Okay. And you should try E on your own, right? I'm not going to go through that. And when you try it on your own, post your solutions on, post your notes, scan your notes, post them for me. Okay. So I'm going to do example 2A. Right. Find the area of the trapezoid. It's 84. Okay. Okay. So let's see the green triangle. Base is x, height is 7. That gives me 7 halves x. This triangle. Base is 6, height is 7. That's going to give me 21. If I add those two pieces together, I get 7 halves plus x. 7 halves x plus 21. That's the area. It told me in the original the area was 84. So I'm going to set that equal to 84. So this one's a little different. We didn't have a base, but we knew what the area was. Well, from here, it's algebra 1. Subtract 21 from both sides. Right? Multiply both sides by 2 over 7. That's going to give me 18. There's my height. Okay? And now you can try example D.